So this is one of the biggest problems to solve in AI right now, and if you can solve it, you can make a lot of money at these companies, and that's hallucinations. So why do hallucinations happen? In this video, I'm going to be breaking down step by step why these hallucinations happen. I'm going to be reading some research papers. I'm going to be explaining it in plain English, letting you all know what's going on under the hood. So stick around. At the end of this video, I'll be showing you exactly what goes on in a large language model, why is it hallucinating, and what you can do to stop it. And there's going to be one model in particular that breaks the rules. So I work as an AI engineer making chatbots for real projects, and there's something that I see quite frequently. So there's people who come to us with a database and they want to put some kind of AI interface in front of it. So it sounds simple, but they always ask, why is it always making things up? So that's the problem. It's hallucinating. So understanding why this happens is the first step to fixing it. But at the core, language models are giant probability machines. So when you ask a question, the model doesn't know how to answer. It's just predicting the most likely word based on everything that it's seen before. So if you ask it, who is the president, and it's seen a lot in its training data about the president being Obama, it's more likely that it's going to associate president and Obama. It's going to predict those words together. So it's not lying. It's just picking the most probable answer for the next word. So here's the twist. Hallucinations don't just happen because of bad data in its training process. It also happens because of the way that we talk to it. So one of the biggest reasons large language models hallucinate is context overload. You see, every model has a context window, basically how much conversation it can remember at once. Researchers have shown that models can only utilize about half of its context window effectively. After that, the performance starts to drop off. And when you stuff too much irrelevant text or noise into that context window, the model starts mixing things up and producing nonsense. So interestingly, Gemini is one of the few models that can utilize all of its context window, but that's still an open research question. But wait, hallucinations still happen, not only with text, but especially when counting and using numbers. Okay, so here's a fun test. Ask a language model how many R's are in the word strawberry. Sometimes it'll say 2. So why does it happen? Because of something called tokenization. So language models don't actually see letters. They see tokens, which are just chunks of text. And sometimes berry can be represented as one entire token. So when you ask the model how many R's are in the word strawberry, it'll only see 2 R's. So that's why it'll produce the wrong answer. So you got context and you got tokens, and they both cause hallucination. So what about the data itself? So that's where it gets pretty interesting. So the OpenAI paper gives this great example. If you ask, when is Mia Holtner's birthday? There's no clear answer. The model might say April 1st, August 29th, or whatever it's seen before. That's because there's no clear, consistent pattern. So pre-training teaches correlation. Take for example, how can I help? It's a valid sentence, but if you spelled words wrong within that sentence, it isn't, because it's seen the first version more. So hallucinations is basically an error that's baked into the training process. Okay, so here's something that really surprised me. We have this pre-training process where the model is trying to predict the next word, and then there's a post-training process based on human feedback. We train the model to basically make these guesses. We don't reward the model for saying, I don't know. So it's always better for the model to guess even though it's unsure about the answer. So if we want to change the way that these models are responding so they can say, I don't know, or I'm not sure, then we need to fundamentally change the way that we're training them. And that's a big ask in research right now. So language models hallucinate because of probabilistic guessing from the pre-training process, context overload and providing too much noise, tokenization quirks, and reinforcement of overconfidence during the fine-tuning process. So the fix is something called retrieval augmented generation. And I provided a whole step-by-step tutorial, and I'll bring it up here where you can watch it, and then I have a Jupyter notebook where you can walk through and learn step by step what retrieval augmented generation is. So just to give you a brief overview of what retrieval augmented generation is, it's basically just giving the model some verified facts in order for the model to reference or source the answers that it's creating for you. So if you found this breakdown helpful, give this video a like, comment down below if you liked it, and you can subscribe, and I'll see you guys in the next video. Peace.